Okay, now if you see, we got 9 routers, and router 1, router 2, and router 3, they are advertising loopbacks. Here we have 1.1.1.1 and 2.2.2.2 and 3.3.3.3 is advertised from these 3 routers. Router 9 will now choose to go this way. Even to reach 2.2.2.2, it will take this path, not the upper path. You know why? Even to go to this 2.2.2.2, it will take the bottom, the below one, not the upper one. Why? See, so the number of hops via router 7 is less. It is only 3 hop, 1, 2, and 3. And the number of hops via 8 is 1, 2, 3, and 4th hop only this autonomous system 10. So that is the reason why router 9 choose to go via 79.7. You see, you got the greater than symbol there. Though it is just 3 hop. The other one is 4 hop. Okay, so here we got a greater than symbol, meaning this is the elected path. Let's check the routing table now. Show IP route BGP. You can see it goes via router 7. It goes via router 7. This is 79.79.79.7. It goes via this way. Fine. Let me trace route and show you. 2.2.2.2 source 99.99.99.99. That's one of the loopback in router 9. So it goes via router 7. When we trace, we see it goes via 79.79.79.7. Why the other hops are not going? That is different reason. I need to check. The trace will be successful now. Yeah. So let us trace one more time. It will go to 7 and 5 and 3 and 2 and 1 and 5, 3, 1 and 2. Seven, 5, 3, 2, 3, 1 and 2. That's the path. 3, 1 and 2. So number of hops is not number of router. If it see number of router, it would have taken the upper path. One hop is one autonomous system. Okay, 3, 1, and the last router is going to be 10, 12, 0, 2. That's it. All right. Now we are going to configure wait so that the traffic will go via the upper path. So not only for 2.2.2.2, not only for 2.2.2.2 destination, even for 1.1.1.1 and 3.3.3.3, if you wish to send the traffic this way, then what we need to do is we need to set wait. Why I am using wait? Why not local preference? Why am trying to use wait here? Why not local preference?
Because local preference will be advertised to all the system.
Okay, but
Wait is only within that router.
okay. So
So wait கொடுத்தனா ஆட்டோமேட்டிக்காக அது எந்த சைடில் வெயிட் அதிகமாக இருக்கோ அந்த சைடில் மட்டும் தான் பார்த்து சூஸ் பண்ணுவோம்.
those things are right, but my question is, why I am not using local preference here? You said local preference is local to the autonomous system, and you said weight is local to the router in which you configure. To the neighbor that you give higher weightage, it will go that direction. I agree all those points. Why I am using weight as an attribute and why I am testing this in router 9, why not I test this in router 1 or 2 or 3? Okay, answer is actually the real answer you already gave. See, my aim is to teach attributes. I choose this place as the better place to teach weight attribute. The reason is I have only one router here. I don't have too many routers. Here I have more than one router. Maybe when I want to teach local preference, I'll come here. I'm just making use of this one, just one router here with multiple paths, multi-homing to teach weight. So even in the real world, if you will have only one router, why unnecessarily configuring local preference? Not necessary. We can go with weight. That's what I mean. But what you gave as answer is the right answer. Weight will be only significant on local router where you configure. That is true. But the reason why I am choosing router 9 is I have only one router there and I want to teach weight. That's the best place.
Is there any compulsion or something like that to use only
No, I can even use local preference there. Even if I use local preference there, it is going to work for me. I can achieve what I want, the result I want. But can I teach weight in this autonomous system with more routers? Yeah, but it will be a little bit confusing one. But here it is very easy to understand weight. That's why I choose there. Okay, so let us go to router 9. Okay, I want to repeat here the scenario. Any destination in AS10. Any destination in AS10. I want the traffic to go this way from router 9. For that I configure weight. Yeah, for any destination from router 9. How do we do that? We go to router, BGP 70, and we say neighbor. What's the neighbor's address? 89.89.89.8. That's router 8. 89.89.89.8. Wait. Straightforward command. What is the default weight? That's local preference.
local preference? Yeah, 0.
Correct. I'm going to give 15.
Yes.
For router 7, it has got 0. For router 8, see, it learns from both router 7 and 8. It learns the roots from 7 and 8. The very first attribute is weight. Now I have set 15 for router 8. So it won't now consider the AS hops.
Before giving weight, can we do like a trace route or to see the routing table in the router 9 for the, oh, we already did.
Mm.
2 is also going via, okay.
Yeah. So now I have already set weight to 8. After doing this, let's check now. See, before doing, we did all this that you asked me. You see, it goes via 7.
Yeah.
Not only to 2.2.2.2, even for 1.1.1.1 and 3.3.3.3, this is going to be the root. Now we have set the weight. After setting weight, whenever you do some changes to attribute, make sure you refresh. Clear IP BGP star soft. I'm refreshing BGP so that the updates will, the changes that I made will be updated immediately to the other neighbors, or if it is needed to be advertised. Now show IP BGP. You
So
can see number
clear IPBGP star soft. So star
all
clear
neighbor.
so the down just
No,
a refresh button.
the word soft will not terminate the neighbor and re-establish. Without terminating the neighbor, it will reprocess. It will redo all the calculations according to the new changes that we have made. Now I can see here the weight that I have set. As a result, the greater than symbol which was here earlier, because of the shortest AS path, now has shifted to this one because of weight, higher weight comparatively. Higher weightage is given for router 8. Now if you trace the route to reach 2.2.2.2 or 1.1.1.1, it will go via 8. From 8 it goes to 6. Let's see. I'm expecting 89, 89, 89, 8 now. That's the S. Correct. So it goes via the upper path and it goes to 6 and then it goes to 4 and then it goes to 2. Okay. So now, not only for 2.2.2.2, even for the 3.3.3.3, which is down after 1.1.1.1, it takes the same path. So now it shows the path. It's the same path via the upper path. The number of hops may be more here because it's trace route, it's not BGP. BGP considers AS as a hop, but trace, every router is a hop for ICMP. All right, one thing that you need to know that because of the weight only it takes this path. And weight that we have set is global. Meaning, what do I mean by global here? We said for all the networks that I learned from router 8, for all the networks, weight is 15. What if I want only for some networks? Or in another word, what if I want only if the traffic goes to router 2, I want the weight to be 15 for this neighbor router 8. Only for that destination, I wish to go via router 8. The other destinations like 1.1.1.1, 3.3.3.3, I want to take a normal route, the route via 7, the default route via 7. Only to this destination 2.2.2.2, I want this path. And the other destinations, I want the default one as per AS, as per the AS ops. Only for this destination, I want the upper path. How do we achieve this? For this, we need to write something called route map along with access list or prefix list. So what I do, I go and remove the global weight configuration.
Right.
I've removed it. And now I'm going to write a prefix list or access list. Which one you want?
Prefix list.
Prefix list, IP prefix list. Give any name ABC. Permit 2.2.2.2/32. I have written a prefix list to match a prefix called 2.2.2.2. Next, I say route map. Any name, I say,
Can give same name.
okay, ABC. And then I say match IP address ABC. If that match happens, set weight. See, that is route map.
Oh, it's other way.
In route map, you have all metrics, not only BGP's attribute, OSPF metric, EIGRP metric, RIP metric, ISIS metric, all metric you can define here. Whenever you see the word policy-based routing, PBR, you need to know how to use route map. Stay. Ante. Only that much. Avlada. Route map, if you know to use, that is what we called as policy-based routing, PBR. So we are setting weight as 15. Now, if you see the route map, show route map, you can see, okay, there are a lot of route maps. I created a route map ABC. Wait a minute, I will remove other route maps so that you won't have confusion. Now this is the route map that I created. You saw me creating this. But did I say anything like permit or sequence 10? No, I didn't. I'll show you.
Just say perfect.
Yeah, no, I didn't say permit also. I said
That's
route
okay.
ABC.
Prefix list.
Yeah,
Perm-
when I create a route map, I did not say permit or deny or sequence, nothing. I said route map ABC, but these are all default. When you don't say permit or deny, it is permit. And when you don't give sequence number, it is 10. Now I want to write another route map with the same name, so I have to say sequence number 11. Now, why I have to create another route map? See, this is like an access list. In access list, whatever is permitted. Whatever is not mentioned, there is an implicit deny at the bottom. Similarly, whatever is matched in this access list, for that it is going to set wait. Whatever is not matched in that prefix list or access list, it will be blocked if you don't write this. When I write this, it is like a permit statement. Permit all other update without any alteration. You see now, this permit which I created now, ABC sequence 11, it is going to permit all the other networks. See, this prefix list is matching only 2.2.2.2. But we also have other updates like 1.1.1.1, 3.3. Those all will be permitted as usual, as normal, without any weight or anything added to it. Normally, as usual.
So rest of
The default. Now I have to now bind it to the neighbor. We have written an access list, sorry, route map. Now I go to the mode BGP 70 and say that neighbor 89.8 should use correct route map ABC in. What does that in means? When this 8 gives me, when 8 gives me, when I receive the update from 8, when I receive, that receives what in. It needs to be according to what this route map says. The route map says that for 2222 add 15, for the rest no, nothing alterate, no, nothing to be added. Okay, now let's verify this by typing show IPBGP. Show IPBGP. You can see here. Wait, I have to clear. Clear IPBGP starts off. Whenever you do some changes to the attribute, you have to refresh. Now let us check. What? Clear IPBGP star from 89, not star, from 89, 8. I'm doing hard reset. It discards and then brings it up. Let me check now. Hey, something is wrong. What am I doing? Show run. I think I have not removed the previous configuration. Let me check. Okay. Show IP prefix. Okay, ABC. That is okay. We are calling only ABC.
we are not using
Yeah. We are using ABC 2.2.2.2. And then show run. Okay, I know what mistake I did. This is what I did. Wrong mistake. PRO route map mistake. I'll show you where I made mistake in route map section. You see, I have said match IP address. No, match IP address prefix list, I should say. Route map. This time I have to mention the sequence number because there are two sequences. And now I will remove this statement and I say match IP address prefix list ABC. If I use only the access list, then I no need to mention this prefix list. I could have used that ABC like before. But this time we did not use access list, we use prefix list, so you have to mention it. See, let me show you why why we have to mention. When you put question mark, you will know. For prefix list, you need to use this keyword. For access list, you can directly give the word if it is named access list or numbered access list. So that's the mistake I did. Let us verify this in the route map and then we'll go and refresh BGP. Show route map. Okay, now it clearly says it's not an access list, it's a prefix list. Last time it was showing access list, I was not really focusing on that. Last time it was very clearly showing you have an access list. No, we don't have access list, we have prefix list. Now it is very clear that it is prefix list. Clear IP BGP star soft, and now you type show IP BGP. Look at this. Only for 222 you have 15 and the path is via 8. Even though the path has got more hops, it prefers to go this way because of weight by ignoring the shortest path. Shortest AS path. It ignores the shortest AS path. It is because of weight. Whereas for 1.1.1.1, it is taking only the shortest AS path. Is it clear? Let's check the routing table now. Show IP route BGP.
So the routing table on R9 is 7321. Why doesn't it code 4?
See, we are focusing on router 2 subnet called 2.2.2.2. It goes via 8. Whereas to go to...
Generally, I'm asking why we not advertising the router 46.46.46.
No, I did not advertise any of this. And I did not advertise 4.4.4.4. I did not advertise 6.6. Too much is not enough actually. Sorry, not needed. Whatever is necessary to understand the attributes I have put here. That's why you don't see that.
No worries. I just want to know again about that map in,
Yeah, okay.
because
Okay. Show run.
it is about in and out.
Okay. Now this router is router 8. This is router 7. In picture, router 8 and router 7. Both are giving update. That update is coming into this router. Do you agree? While the update is coming in from this neighbor, if it matches 2.2.2.2, then add 15.
From the advertising.
When the advertisement comes in, look for this 2.2.2.2. If it is there, then add 15. That's the meaning.
Okay. Now it makes sense.
You see? All right. So we have seen here route map without route map. Two things we have seen. When do we use route map? When we are focusing on one particular destination, not all the destination via 8. Via 7 and via 8, I can reach all these destinations. When I want to have a common policy for all destination, then I no need route map. I can globally configure that. That's what we did in the beginning. Yeah,
Yeah.
we did globally configuration. Globally, how we configured? We did not use route map. How we did that? We went to this neighbor statement, and after the neighbor address, we said wait. We did
Wait.
not use local. We did not use route map. We straight away said wait, and then we gave the value. But when it is for a particular destination or group of destination, we need to use route map. And in route map, we learned one thing. There is something called implicit deny even in route map. So after writing the route map that you want, we also need to write another route map with the same name, but the next sequence number. The default here is 10, so you should not give 1 or 2 or 3. You should give 11 or 12 or 20 after 10, any number, and create a route map, just an empty route map, that is to allow the other updates to come in with no change in it.
Okay.
Right? So I think we'll stop here. You